So that is a parametric equation. A little different than what you've probably seen before, right? Okay? You're used to seeing lines and parabolas and cubics and all that stuff, right? Okay? Parametrics are a little different in what we do. Okay? So, let's dive into parametrics. By the end of class today, you'll graph this, just so you know. Okay? All right? That's our goal today. Okay? So, a parametric equation is an equation. Well, let's first talk about a regular old function. Here's my paper that I was looking for. Okay? So, if you had a function, doesn't matter what kind it is. Okay? Could be linear, could be quadratic, could be cubic, could be quintic, could be to the 18th power. I don't care. Okay? What is the beginning, the first time you did it, way of graphing? What did we make in order to graph a function? Anybody remember what we made? We made a t-chart, yep, an XY table. Okay? Alright? So we made a t-chart. And from that t-chart, we then what did we do?
Ordered pairs.
But how do we get the ordered pairs? Picked an x value. So you picked here, right? Right? You just randomly pick some numbers in there, right? And then what did you do? You plugged those numbers into our function, and that got us these, right? Okay? So in terms of variables, our x was the independent variable. And our y was the dependent. Okay. Then, to make the graph, what did we do? What did we do to make? We plot the points. So we plotted x comma y. Oops. Oh, come on now. Okay? But really, what we're plotting is we're really plotting x, comma, f of x. Right? Okay? With parametrics, we introduce into that scenario, why is it acting all funky now? Come on now. We introduce into that a third variable t. Okay? So parametrics have three variables. Now, we still want to graph it on a two-dimensional plane and a Cartesian coordinate system. So somehow we've got to work those together. And the difference between parametrics is that t is what's called the parameter. x and y then are different functions of the parameter. That's why these are called parametric equations. Okay? So x and y each are different functions. Focus up here, not on her cheese and her crackers. Okay? Alright? So x and y are both functions. Okay? Which then means that t now becomes our independent variable. And both x and y then are our dependent variables. So now we still plot our points x comma y. But really, we're plotting f of t, comma, g of t. We have to plug in t into our x function. Then that gets us the x value for that point. Then we have to plug in t into our y function, and that gives us the corresponding y value. Then we plot x comma y. Okay? You've been working with a parametric function for the better part of first semester and second semester. The unit circle is a parametric equation. Okay? What is x on the unit circle? It's cosine of theta. Okay? What's y? Sine of theta. So what's my parameter on the unit circle? Theta. Theta is my parameter. It's what I change, and then, so theta, I pick an angle, and then that gives me the corresponding x value and the corresponding y value that ends up plotting the circle. Okay? So this is a parametric equation. We've been working with it since the end of October. Okay? Let's try a different parametric equation. Okay? So we're going to graph this first by hand, then we're going to graph it on the calculator so that we show you how to graph them in both ways. Okay? So, there are 4 essential parts to a parametric equation. Okay? The first essential part is x defined as a function of t or theta or something else. Okay? So that's the first part. You need to have what x is defined as. It will be in a function form or in an equation form. X equals something. In this case, it's t squared minus 9. That's our first part. Our second part is going to be what y is defined as. Okay. In this case, y is defined as 2t plus 1. Now, the third thing is one of the more important ones. Okay? The third thing is what we are restricting our t values to be. Okay? So in this particular case, I'm restricting t from negative 3 to positive 2. So I wouldn't try a t-value of 17 because it's not in that negative 3 to positive 2 value range. Okay? I'm only going to try t-values between negative 3 and positive 2. Okay? The fourth part I'll get to when we get onto the calculator because it only happens on the calculator. And so I'll show it to you when we get there. Okay? All right? So we need to find some points that go along with this parametric function. So what I'm going to do is, instead of making a t-chart, because a t-chart only has x and y values, I need a third column because I've got 3 variables. I'm going to make, I don't know, what do you want to call it? An h-chart or something along those lines. Okay? So I'm going to make, I don't know why it's not letting me scroll today. Okay? So I'm going to make a chart that looks like that. Okay? So my t-values I'm going to set at negative 3, negative 2, negative 1, 0, 1, and 2. I want the values of t between negative 3 and positive 2. Now, what I'm going to do is I am going to put negative 3 as my t-value. I'm going to put it into my x function. Negative 3 squared is, negative 3 squared is 9 minus 9 is 0. So the x value that corresponds with a t-value of negative 3 is 0. Then I'm going to put negative 2 in for x, or in my x function. What do I get there? Negative 5. Negative 2 squared is 4, minus 9 is negative 5. Then I'm going to put negative 1 in. Negative 8. Then I'm going to put 0 in. Negative 9. Then I'm going to put positive 1 in. Then I'm going to put positive 2 in. Negative 5. Okay. Now I'm going to switch to my y values. And I'm going to put negative 3 in for t in my y function. So what do I get? Negative 3 times 2 is negative 6, plus 1 is negative 5, right? Plug in negative 2. Negative 3. Plug in negative 1. Negative 1. Plug in 0. 1. Plug in 1. 3. Plug in 2. 5. Right? So now the point that I'm going to plot is going to be 0, comma, negative 5. One, 2, 3, 4, and 5. So right down there. The point that I'm going to plot next is going to be negative 5, comma, negative 3. 1, 2, 3, 4, 5. 1, 2, and 3. Negative 8, comma, negative 1. 6, 7, 8. Negative 1. The point negative 9, comma, positive 1. Negative 8, comma 3. Negative 5, comma 5. Right there. Okay. Now, when I go to draw my graph stops because I don't want t-values outside that range. So when I draw my graph, it's not going to continue on forever and ever and ever like you're normally used to. It's going to stop right there, and it's going to stop right there. They don't go on forever. If my t-values were negative infinity to positive infinity, yes, they'd go on forever. But I've restricted my t-values, so my graph is restricted. If we go back a couple of slides, if you'll notice on this funky one that I started the class with, it's stopped right there. It doesn't continue on forever. And it's stopped right there. It doesn't go on forever. It's a finite graph. Okay? All right. Now, let's go to the calculator. Okay? So, what you need to do on the calculator is, I would start, but again, this is just me because some of your calculators might still be on the lab that we were doing the last couple of days, and you don't know who was using the calculator before you. So when I start a calculator, I always start with a new document. I'm a document guy. I'm not a Sketchpad guy. Okay? So I always start with a new document, which probably is going to make me not save something, which is fine. But we're going to want to add a graph. Okay? Doesn't matter. Okay? Alright? So I want to be in this graph. Now, the downfall with the standard graph is that it's in function mode. Okay? And where I want a graph like a y equals mx plus b. Okay? Or a y equals 4x squared minus 13x plus 12. Okay? That's that one. That's not parametric. Okay? So what I need to do if I'm graphing a parametric is I first need to go into menu, and then I need to go over to number 3, graph entry edit. That gives me a list of 8 different types of graphs that the calculator can graph for me, and I am going to want to go with parametric. It's number 4 on mine. Now what that has done is that has switched my graph entry, or my function entry point, my equation point on the graph from one line to the 3 lines that I need. Okay? So I would define my x as what my x is defined as. We defined it as t squared minus 9. Then, my y value was 2t plus 1. Okay. Then, my t values, I said, were from negative 3 up to positive 2. So I set those. Then I said when we get to the calculator, I'll tell you the fourth part. And the fourth part is called the t-step. The t-step tells the calculator how often you want it calculated. When we did our graph before, here our t-step value was 1. We went with whole numbers for our t. Okay? What the graph or what the calculator is saying here is that it's going to calculate a value at t equals -3. Then it's going to calculate the next value at t equals -2.87. Then it's going to calculate the next value at t equals -2.74. Then the next one's going to be at -2.61. And so on and so forth. It's going to calculate all of those x's and y's and plot all those points at a t distance of 0.13. Okay? All right? Now, when I hit enter after I've done all that, and tomorrow we'll get to what happens if we change our t-step values. We'll get to that later on. Okay? And so when I hit enter, there is my function, which looks remarkably the same as, save it here, and then let me put it in here, and it looks remarkably the same as, over here, and then paste it there, as our other one. Okay. All right? So there's that. Okay. Now, the last thing that I want to talk about is, why am I going there as a previous page? Okay, is I would like to do something that's called eliminate the parameter, which means I want to eliminate t. I want to get my parametric function into regular x and y form. Regular x and y, or I should say function. I want to get my parametric equation into xy function form. Okay? Now, the way I'm going to go about doing that is I'm going to first rewrite down my functions, or x equals t squared minus 9, and y equals 2t plus 1. I want to get rid of t in both of those equations. So, let's brainstorm. How do you think we could go about getting rid of t in both of those equations? What do we think? All right, what do we come up with?
T alone.
Where?
So, like, I guess that you can, for the y function, you can like add one to t alone.
So isolate t in one of the equations, right?
Yeah.
Okay, and then what are we going to do with that?
We
Substitute it into the other one in place of t, solve for it, and that's going to give us our xy equation. Okay, that's one way. Anybody come up with a different way? That's the easiest way, which I'm hoping everybody came up with. The other way is you solve both equations for t, set them equal to each other, and then do that. Okay, but that's doubling your work. Okay, so which equation do you want to solve for t? Work smarter, not harder. Want to solve the y equation for t. Okay, so I would subtract 1, and then I would divide by 2. Right? Dividing by 2 is also what? Multiplying by a half. So I could write this one as 1/2 times the quantity y minus 1. Those mean the exact same thing. Might be a little easier to put that in than the fraction. Okay? Never know. So then I go over to my other equation and I say, okay, so x equals my t value squared minus 9, and my t value was 1/2 times y minus 1. Right? So that gives me x equals 1/4 times the quantity y minus 1 squared minus 9. One-fourth y minus 1 quantity squared minus 9. What kind of a shape in algebra circles is that? Where one variable is squared and the other variable isn't. There's what? That's parabolas. Okay? Where one variable is squared and the other one isn't is a parabola. Normally, we have the x squared, right? And that's a parabola that goes up or down. But in this case, the y is squared, so that's a parabola that goes left or right, correct? Okay? All right? So the vertex then would be, the vertex of this parabola would be at x equals -9 and y equals +1. Because, remember, we think opposite inside the squared part. Okay, well, let's go back to our picture. Well, our vertex, this is like a parabola, right? Opening up to the right with a vertex at -9, +1. Okay? The only difference is, if I were to graph, oh, come on now, why is it acting up? Why is it acting so goofy? Why won't it let me go scroll down? The only difference is that this one would go on forever and ever and ever and ever as it opens to the right. Okay? My parametric one, I've taken just a chunk out of. Okay? Now, in the last here couple of minutes, what I would like you to do is I would like you to actually graph. Sure, now it won't come. There it goes. There is that funky one that I started with. Graph that one on your calculator, and then I want to explore it a little bit. Okay? You can type in the word pi, or you can use the pi key. Okay? All right? So I zoomed out a little bit on mine. Now, what I wanted to show you is that if you trace this, okay? So let me see if I can zoom. Actually, I can't because I'm in here. So if I trace this, I'm going to go over here onto my computer. And if I trace this, sometimes my function is moving. I'm moving to the right. So I'm getting bigger t values. If you'll notice, tough for me to hear. Let me move the cart over a little bit. So I'm getting bigger t values. My t value is increasing. And sometimes my function is increasing. Like right now, sometimes my function is decreasing. Sometimes I'm going to the left. Sometimes I'm going to the right. Okay? Just because your t value increasing doesn't necessarily mean that you're going to be moving to the right at all times on the graph. Okay? In this case, as my t value is increasing, my function is sometimes going up and to the left, sometimes it's going down and to the right, sometimes it's going up and to the right, sometimes it's going down and to the left. It's moving all over the place. But now here's the thing. Here, don't even be rude and start packing up when I'm talking about this stuff. Okay? Notice as I get up here to a t value of, I set my t values at 4 pi. So as I get up here closer to 4 pi, it ends, yes, but then now when I go to the right one more, it jumps all the way back to the other end of the spectrum. So it jumps to -4 pi. It doesn't keep going at like 15 or so, a t value of 15. It jumps back. And if I go the other way, it would do the same thing. So here I am at the end, and it jumps back to the beginning. Okay, or so on and so forth. All right? Have a good day.